right. Now, I fully expect you to be confused to begin with about exactly what, guys?
What should we label this?
Direct variation. Now, like I said, I fully expect you to be confused starting out. We'll be spending several days on this. I did break up the homework though, so I'm only going to teach you one part of it, but I don't really expect you to have an understanding of the whole concept as a whole until we've spent a few days on it. So for today, the most important thing for you to know is that a direct variation equation looks like this.
What is
Now,
that?
this, now, what this says is that our y value has a direct relationship with our x value, which means that there is one thing that you are going to multiply every x value by in order to get every y value. Now, we'll look at direct variation in this section. We'll look at graphs that show direct variation. We'll look at tables that show direct variation. But today we're just focusing on equations that show direct variation. Now, all this means is that examples of direct variation equations look like something like this. This is a direct variation equation because in order to get your y values, all you have to do is take your x values and multiply by 3. Because 3 is our constant of variation here. Our y value is equal to the x value multiplied by 3. Is this x times x?
No, it's 3 times.
Right, so I said your y value is equal to your x value multiplied by 3. Okay, so whatever your x is, you're going to multiply it by 3. That's going to give you your y. You know, if you were to put it in a table, which we'll look at t-tables a little more in depth later, but a t-table is where you pick an x value and find the matching y value. So like if x was 1, then y would be 3 times 1, which is 3. If x is 2, then y would be 3 times 2, which is 6. If x is 7, then y would equal 3 times 7, which is 21. Now, guys, as you can see here, there's a relationship between every x and y. This y is 3 times that x. This y is also 3 times that x. This y is 3 times that x. That's direct variation. Now, guys, I just picked one. Now,
Which makes sort of sense.
okay. Now, your k value can be any number. It doesn't have to be a whole number. We could do, well, let's do this first.
Let's just do wholes right now. Let's just do whole numbers.
No. All right. Y equals 1/2 x. Now, once again, this is direct variation because your y value is equal to some number, in this case the number being 1/2, multiplied by your x value. So if x was 4, then y would be 1/2 times 4. 1/2 of 4 is
2.
2. So my y value here would be 2.
Wait,
All right.
can you say that again?
If I'm replacing x, and here I'm just picking, for these t-tables, you just choose your x value. You pick whatever you want.
You pick your x
Yeah,
value, so
we're
I
just
can pick
picking.
1.
Yeah, you're not gonna have to make, guys. You're not gonna have to make t-tables tonight, but I want you to see the direct variation. So we're making them. I'll teach you more about how to make them later. But I'm just picking x value. So I picked 4. Well, if x is 4, then y is 1/2 of 4, and 1/2 of 4 is
2.
So that's why my y value there is 2.
So you're pretty much
someone else, what's another x value?
4. 5.
We just used 4.
7.
10. Okay, we'll use 10.
Wait, but then how come?
So y equals 1/2 of 10. So my y value here would be 5. Multiplying by a half makes it get smaller by a half.
Miss Nichols, is this what you're saying?
Now,
Wait, but
all right.
how would you?
And then if I did 12, y equals half of 12, which is 6. So again, this is direct variation because there's a direct relationship. 2 is half of 4, 5 is half of 10, 6 is half of 12, just like 3 is 3 times 1, 6 is 3 times 2, 21 is 3 times 7. So there's a direct relationship between the x and y. You're multiplying the x value by one thing. Every x value you're multiplying by the same thing to get every y value. Now, like I said, your main thing you're doing tonight is just going to be identifying whether something's direct variation or not. So let's say I have this equation. Is this direct variation? Yes or no?
Yes. No. Yes.
Is it y equals a number times x?
Yes. Yes. Or no. Is it always
So
y?
that's going to be direct variation. Now,
Yeah, can we just put check marks on our homework?
that's fine as long as you write but you gotta write the equation down, and some of them you're going to have to solve first. What about this one?
Yes. Yes.
Is it y equal to some number times x?
Yes.
Yeah, that's direct variation.
No. No. Yes. 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 Yes.
It is some number. Again, it doesn't have to be a whole number. It doesn't have to be a positive number. Okay?
Can it be a mixed fraction? I thought I was right. The next one's going to be a wrong one, right? Yes. Please do a wrong one. Please. Yeah, no! Yes! No, it's wrong.
No. This is not y equals something times x. It's y equals something times x minus something. There's not a direct relationship because you're not doing one thing to x to get y. You're doing two things. Okay? It's only direct variation if you're multiplying x by something in order to get y. So this is not direct variation. Now, of course, you know it can't really be that easy. We got to throw in a little something. Now,
I think I have this down. It makes sense. You just have to.
all right. Now, where it gets a little tougher is I could give you something like this. Now, what's different about this one?
You put a +3.
Okay, right. I don't have y
But it's still the
equals.
same thing.
So, before you can say whether or not it's direct variation, in case we run out of time, before you can say whether or not it's direct variation, you have to solve it for y. We have done solving equations before. You do this just the same. If I want to get y by itself, what is in the way? Huh? 3. And I am adding 3, so that means to solve I need to subtract 3. And if I subtract it from one side, I subtract it from the other.
Subtract it from the other.
So I get y equals, and now these 2x and minus 3 are not like terms. You can't combine a variable with a constant. So this is just going to be 2x minus 3. Is that direct variation? No, because I have multiplication but also subtraction.
So that will be incorrect.
So, but you cannot just look at it. When it says y plus 3 equals 2x, you can't go, oh, well, that's direct variation. It says equals 2x. No, because it doesn't say y equals 2x. It says y plus 3 equals 2x.
So we just have to write down, like, on our variables, put y plus 3 equals 2x.
You would write what I wrote. You'd need to rewrite it as y equals. So,
But do we put
all right.
the minus 3 minus 3? So
Yes. All right. If you have,
can you, like, give us a problem? I think that's what's in the
let's say this one. Now again, is this already in the correct form? No. So if I want to get y by itself, what do I need to do?
Divide x.
Divide by x. Perfect. This is multiplication. It's, guys, even though it's a variable, you can subtract and multiply and divide variables, same as numbers. So since this is multiplication, to get y by itself, I need to divide. So I'm going to divide by x, and it'll cancel out, and divide by x over here, so I'll get y equals 4 divided by x. Is that direct variation?
No. Yes. Yes. Wait,
No, because it's got to be a constant times x, and this is division, so this one is not direct variation.
That makes